Thank you very much. So I'm talking about emissivity and how emissivity affects the tempering process, and I'm discussing potentials to use this phenomena for improving tempering. First of all, I'm from Suragus. Suragus is a company from Dresden. We are founded 2010, and we are having roughly 50 people, and we're focusing on one testing technology, which is an inductive testing method called eddy current testing. Today, we look at emissivity changes during tempering processes, and many people are aware of the effect that the emissivity improves during the tempering process. So the changes of the emissivity are from 10 to 40%, depending on the type of glass and of the type of coating, and of course on the temperature. And the higher the temperature, the more effect on the emissivity can be observed. This is an example. Some go up to 20%, some go up to 40%. It depends really on the glass and on the coating. The emissivity affects the heat distribution during the tempering, and this is very important. And it also affects the infrared camera reading. Yeah. So the short version is emissivity matters, and it's clear that if I have an emissivity coating on top, that the heat distribution is different from top and bottom. So furnace makers operate with different ways: radiation, convection, thermal conduction, to level that. The aim is always to have the same heating from the top and from the bottom, so you have optimized stress indication or induction. And again, emissivity matters, and we've been discussing this for several years here at GPD, and we decided to let's bring some practical tests to it. We did this work. It was supported by Jorma, who has a consultant company, and he knows so many people in the field, and he can open many doors, and he has also some experience with emissivity measurement over, I don't know, 25, 30 years. And Jorma was very helpful with getting the measurements, and thanks to you. And today we show some of these results which we generated. We did measurements before the tempering and after the tempering, and we did run this through different glasses at different measurements carried out at different sites here in Finland mainly. And we observed different glass. We measured different glass thicknesses, different glass manufacturers, and used different furnaces. And the measurement was done with a portable device, which is a handheld device to measure the emissivity. And this is basically based on a technology called eddy current testing. There's a portable version, there are single-point laboratory versions, there are imaging versions, and of course inline. Inline is the most popular one. It's generally applied for measuring mirror coatings, measuring TCO coatings in solar or smart glass applications, or also in architectural glass. Everything where layers are deposited, where layers are modified, or layers are removed. These are applications for eddy current monitoring. Eddy current is known by many people, but I give you a very brief summary. Basically, what is happening, we apply an alternating current to a coil. This is generating a primary electromagnetic field. And if you bring a silver coating into this field, eddy currents are created. This changing current is generating a secondary field, and this secondary field is then picked up by the sensor and is characterizing the field and then correlated to sheet resistance or emissivity. There are different setups. It can be measured only from the top, like in the portable, but it can be also measured from the bottom or also in transmission mode. And it can be applied for single-layer systems, and it can be also applied for multi-layer systems, like in the LowE stack. There are different silver layers, and basically the tool picks up all the silver layers which are there and is calculating the result. It's not only applied for emissivity measurements, sheet resistance, metal layer thickness, also defects, uniformity. We also characterize laser scribing, and some indirect effect is also glass thickness measurement. The underlying formula to measure emissivity is shown here. There's a conversion by the Maxwell's equation and Kirchhoff's law, which I save you today. But basically, the short version is shown here in the formula. And in result, there are different potentials for considering the emissivity. And now I'm coming back to the tempering process. And over the years, we have discussed different potentials, how this emissivity information can be used to improve the tempering process. And one, of course, is already done by many companies to some extent, that they know that the heat absorption of the glass is affected by the emissivity, and they use certain recipes for different glasses, but it's more like categories. The consideration of that can help to achieve a better tempering result. So the idea is to optimize the tempering effect. It's also, if you imagine that the emissivity is changing from up to 40% during the tempering, so there's also a change during the process which can be also considered. Yeah. So the idea is to consider emissivity, glass thickness, loading, and many, many more things during the process, and feed this to the tool or validate at least the recipes. This is the first step, to validate what you have on the table. The second one is to fully automate the tempering process. The motivation is often to save costs by the operators, and there's some other reasons why loading and unloading is there's some potential to automate that. And of course, if you do automated things, then always the recipe selection needs to be also automated. And this is an option that the furnace already knows what's coming. So you have a clear recipe handling. The third one is that if you do infrared temperature measurements, then the emissivity of the glass affects the temperature reading. And since you use the temperature as a quality check, the distribution of the temperature for the assessment of your tempering process, it's also good to have a good temperature assessment, and the emissivity can be also fed into this infrared settings. The fourth idea is to use the emissivity improvement. So at the moment, the emissivity, not many people know what the emissivity is before the tempering of their glass and what is it after the tempering. Yeah, and sometimes the emissivity becomes much better than stated than in the data sheet. Yeah, and the question is, who can use this benefit? Who can maybe also sell this benefit? If a furnace maker is able to get the emissivity not only down to this value, but maybe to this or that, then this is a clear improvement. And maybe in the future, some people are also ready to pay an extra a little bit for even better glass. So we are also doing a lot of stuff in the solar industry, and there every cell is measured and sorted. 23.5% is sorted with 23.8%. So there's a clear sorting, and so at least there's some potential to explore also the unconsidered improvements. And the question is whether customers would be ready to pay a mark extra if this is like 10% better emissivity, and the furnace maker can get this out of the glass. Yeah. Then there's also some ideas which we have also considered in this discussion here. We wanted to check the homogeneity of the coating, of the silver coating before the tempering and after the tempering, to see whether there's what is the variation before and what is the variation after, and is there something that we can use or that we can also benefit from that. So these are the 5 potentials that we want to discuss here. In general, it's basically is set up where we can measure from the top, from the bottom, or in transmission mode, and there are different zones where the sensors could go, in the loading zone, or in the entrance or exit, or in the unloading zone. So this depends then on the setup. Yeah. Okay, let's dive into the results. We were measuring before and after tempering. So basically, after loading, measuring on different positions on the glass, and then after the tempering, getting the data. That was the process, and we were also looking at the recipes, the temperature which was applied. We also looked at the infrared images, and we tried to collect as much data as possible. And the results look like that. For instance, here we have the emissivity before the tempering, and here we have the emissivity after the tempering. And the other values are sheet resistance. Since sheet resistance and emissivity correlates, I show them both. And this is now the first test, and we've done this with same glasses and different glasses and different heating profiles and also different glass thicknesses. So there are different results here, which I've just run through. The overview is here. So in this type of glass, so I don't say the glass type here, but basically we have an improvement which is roughly 20 to 25%. And we also looked then at the mapping. So we took manual measurements on different positions of the glass. So we have a homogeneity map in green here. Before the tempering, so we have a sheet resistance of 6 roughly, and afterwards 3.8. And we look at the homogeneity before and after. So, and sometimes there was something interesting, sometimes not. So we need more data to explore this in detail. So here's a 6 millimeter glass, and here is also another 6 millimeter glass where we took more data points. So we see some slight variation in the silver coating before the tempering, and then after the tempering, it's more like another profile that the outside is a little bit different. So, but we see different processes here, and also the sputtering depends on how the glass was manufactured this way, and how it ends up on the tempering table. There are a lot of differences. Yeah. So this is just the status which I present here. So this was a lot of work to get this data, a lot of driving around, a lot of measurements with this portable. There's work in progress. We're going to continue from here to collect more data. And for the moment, I would like to summarize what I'm trying to say here. So the emissivity affects the heat distribution during the tempering process. We know that, and there are several other parameters that follow that: the bending, the stress, how the glass lies on the rollers. Dedicated recipes for certain emissivity coating types, glass thicknesses, can provide more potentials for excellent tempering processes. So it makes a difference whether the glass has 3.7 or 3.9 sheet resistance before, and this can be measured, and it can be also helpful when new glasses is run on a tempering furnace to find the first recipes. Yeah. Then we saw that the emissivity changes are quite high. The variation is 10 to 40%. We also want to look at pyritic coatings at some point. We haven't done that yet. And so this is about the tempering. The potentials that we see is to optimize the analysis of the emissivity which is on the tempering entrance, and consider this very precise for a very defined recipe selection and the recipe optimization. Also to use this for fully automated process control and automated loading and unloading, so automated recipe selection and validation. Use this to improve the infrared readings from the temperature, from the camera, from the infrared camera. Use the emissivity improvement as value add. So there is a value add, often unknown. It's might be a value add also for the end customer. If he gets more out of the product, why not tell him about it and ask him to add also some extra for this. And there might be also some potentials to assess the homogeneity of the tempering process and get more insights from that. Last slide, this metrology summary. Here I introduced eddy current monitors, which are able to measure the emissivity, the sheet resistance, and metal layer thickness. And it's a non-contact, very fast measurement, which is measuring also through the encapsulation. And there are different testing setups available. Portable and inline are the most relevant ones here. If you are interested in exploring this topic, you are welcome to contact me, Marcus. I'm also here today on the event later. And we are in Dresden. Come to me and discuss these ideas. And thank you very much for your attention. And I'm also thank Jorma for his support in this work here. Thank you.
Okay, thank you, Marcus, for these insights into that very specific business. Any questions from the audience? There's one.
Thank you for the presentation. Interesting. I was wondering, is this device also specified in the EN norm to measure emissivity? And if not, what's the relation with how the norm says that it should be measured?
It's hard to hear. Can you repeat, please?
Yes. Oh, just the microphone worked. Sorry. I was wondering if this technique is a way of measuring that it's prescribed in the norm to measure emissivity, and if not, what the relation is with the methods that are suggested.
Yeah, very, very good question. The way this emissivity is measured in the industry, which I showed here, I think this is done this way since 30 years. So this formula, which I have shown, is from the end of the 80s, and it's applied in the industry for many years. I'm not aware of that is a certain norm, but it's a physical relation of the sheet resistance to the emissivity. I have also a slide on that. It's a little bit complicated. It's also on our website explained. So there is a clear correlation, but I'm not aware in which norm this is available. Yeah.
Okay, any further question up there?
Thank you for your presentation. Actually, I have two questions. My first question
Can you
is,
speak a little louder? Or, yeah.
my first question is, did you compare any color changes with emissivity also? I mean,
no, not yet, but there are some phenomena. I didn't show all the results that we did. So we also tried to run wrong recipes on the furnace. Of course, not everybody was happy that we want to use glass to run wrong recipes. So that's somebody needs to pay for that, of course. But there are some effects that we suspect that cause optical changes, which are also visible in the electrical performance or in the emissivity. We have some indication that this is true, but needs to be further validated.
and my second question is, I don't know if it's written in norms, but mostly in production lines, emissivity is measuring with FDR instruments. Did you compare or join in the round-robin tests with eddy current tests and FDR instruments?
I'm not aware of it.
Soon there will be actually it has already started, but samples didn't dispatch yet, and there will be a big round-robin test around Europe. I mean, if you are interested, I can ask providers.
Yeah, let's talk.
Mm-hmm.
Nice,
Okay.
thank you.